The next example we're going to look at for security protocols is that of GSM devices and GSM networks. So GSM is the way we communicate using mobile phones, or it actually can be more than just phones. But they're called handsets. So a handset, you can think of them as basically phones. They each have a SIM card. You guys get a SIM card from your um, your service provider. Put that into the phone, and then you can communicate with a base station, which is eventually going to be converted to a wired signal that can communicate to landlines, if anybody has landlines anymore, through a circuit switched path to all kinds of phones across the world. Or it can also um, communicate between cells, or what are called visitor location registers. And so, visitor location registers keep track of all the cells that you're visiting. That is, if you have a home environment or a home location register and a visiting location register. So, for example, your home location register, if your area code is 715, would be somewhere um, in western Wisconsin. Okay, so there's a lot of stuff happening. There's a lot of communication. You're going between cells. You're going between these transceiver stations, things like that. And there's actually encryption used all over. Each SIM card will have its own 128-bit individual key, that is KI, and that's used to basically prove who you are, so that you are not, someone doesn't use your account to pretend that they are you and things like that. Okay, so once again, GSM, each handset SIM has a 128-bit individual key, KI, and the home network sends the visited network a bunch of data, a random number, and SRES, which is a 32-bit signed response from a mobile station and home, and then a key, KC, which is a 64-bit ciphering key used as a session key so that you can encrypt your communication. Okay, so the key is, so the main idea is that SRES ORed with KC gives you this RAND number, and that's encrypted using KI. So the handset communicates with the networks, and this is where you use the security protocol. The handset sends your IMSI number. I'm blanking on what that means, but I have a link here. It's like international something identifier. It's like your IMEI number for your phone. And then the network in turn replies with the RAND, which it computes. And the handset sends the network the SRES that it computes along with some traffic encrypted using KC. So your voice communication is encrypted, but it's a pretty simple key, and you saw here KC is 64-bit. So when we get to the chapter on cryptography, we'll see that 64 bits is not that strong an encryption system. It's not likely to be. Okay, so the successor to GSM was 2G, and then there was 3G. 3G or UMTS protocol fixed a lot of problems with these weak ciphers that were used in GSM, and also vulnerability to rogue base stations that you could have with GSM. You could have base stations that were, and you could set up base stations to like figure out where people are going, things like that. And you might have heard that people suspect some government intelligence agencies of putting these base stations all over to track people, things like that. And there are all kinds of things happening that we'll talk about in networking. Like, for example, Apple makes it so that it's not easy to identify you if you're going out in public, because through these rogue base stations. Okay, so a couple of other things. This random number, this random code is not exactly random, but it's encrypted with the K, is a combination of four things. That is the res. I'm going to scroll back up. And oops, I didn't have it here. All right, so there's a piece of information called res. We don't have to get into it right now, plus some keys for confidentiality, integrity, and anonymity, things like that. You combine all of these things and encrypt it, and that's what you're actually handing out. So in 3G, the SIM talks to the home environment and sends once again the IMSI number, international mobile subscriber information, or ID, and the home environment responds to the visitor location register. So this keeps track of all those places that you're visiting or roaming, sends this information, and we don't have to look at all the details. The VLR then responds to your handset or your SIM, giving you all this information, and then you respond back with the rest code that you compute in your handset, and then you're off and running. Okay, you don't have to memorize all of these things. This is just to let you know that we can use the same protocol notation that we've been using so far to essentially have your phone authenticate with your cell network cells, and also enable you to send encrypted communications. Okay. By the way, all of these slides with the white background, they're just for your own information. That's probably, it's not going to be on the quiz. And so you don't really have to worry about it. They're sort of extra. So there are formal methods for validating protocols. There are many protocol errors that result from using, let's say, the wrong key or not checking freshness, things like that. And we saw examples of these as we went through protocols. So what are formal methods? They are basically like something that a person would use to check if a protocol is working, or it might even be an automated way to prove that a given protocol will work. So the thing you want to check is, will a protocol work correctly, and maybe is there an attack that will succeed, and come up with an attack. So that would be the output of a formal method. One of the best formal approaches was one called Burroughs, Abadi, Needham. So Needham is the same person as the Needham-Schroeder protocol, and so this is called BAN for the three authors, and it's called BAN logic. And basically what it does is allow you to reason about the beliefs of principals in a protocol. Does it make sense for the principals to have a reasonable confidence in a given protocol? So the core of this BAN logic is, some message is true if a principal A is an authority on this message and A believes M. A believes M, the message M, if A once sent out this M and this M is fresh. So A itself, if A itself sent out this message and it is fresh, then you could say that A, quote unquote, believes M to be good. Another principal B believes A once X that was said by A, and B sees X encrypted under a key that B shares with A. So if B has reason to believe that there's a communication from A that was encrypted using a key that B shares with A, then you can say that B believes A. So this is the core of the BAN logic. The idea is, if you can show all of these things and you have a reasonable amount of belief in a security protocol, and you know that it's not going to fail. Okay.